Hi, this is Guntuka Srinivas. Welcome to Varinya's Photon Online Educational Academy for IIT and NEET examinations. This channel is mainly concentrates on the basic concepts associated with the physics, chemistry, and mathematics subjects required for the IIT and NEET examinations. In the previous session, we have seen about the displacement versus time graph. Let us see in this session about some numericals associated with velocity. And if you like the channel, please share it, subscribe the channel. Once again, I welcome you all for the IIT physics classes. Let us take up some numericals. Let me take up the first one. Displacement and time relation is given below as S is equal to TQ. S is equal to TQ. Find the velocity. At t is equal to 1 second and at t is equal to 2 seconds. This is the question given. Observe, displacement versus time relation is given as S is equal to TQ. This is the relation provided to us. Okay. It requires velocity at t is equal to 1 second and velocity at t is equal to 2 seconds. That means, observe the problem. Velocity at a particular instant t is equal to 1 second is asked. Similarly, velocity at a particular instant t is equal to 2 seconds is asked. That means, velocity at a particular instant of time is known as instantaneous velocity. That means, is indirectly asking the instantaneous velocity. S is equal to TQ is the relation. S is equal to TQ is relation given. This is the given relation. Yeah. Now, observe, let us say this is the path of travel journey. Here, at a particular time, t is equal to 1 second, it requires the velocity. Let us say I am giving a point A. I am giving a name A at t is equal to 1 second, a particular instant. Similarly, it requires velocity at another particular instant at t is equal to 2 seconds. I'm giving a name B. It requires this. That means during the entire path of travel, at t is equal to 1 second, that particular instant at A. Similarly, at t is equal to 2 seconds, at that particular instant B, it requires the velocity. Okay. Velocity at a particular instant is known as instantaneous velocity. So he's asking V instantaneous, V bar, vector instantaneous velocity. What is instantaneous velocity? ds by d. For a small time period, d stands for small displacement, small time period, ds by dt. This is the formula. Clear? Okay. Now observe. At t is equal to 1 second, require the velocity. What is the formula? V bar is ds by dt. ds by dt, instantaneous velocity. Okay. And relationship given is what? S is equal to TQ. S is equal to T. Differentiate it. When I differentiate it, V bar instant, the differentiation of this ds by dt, which is equal to 3 into t square. 3 into t square. Observe. Observe. Differentiation of d by dx of x to the power of n, formula is n into x to the power of n minus 1. This is the formula. Differentiation of d by dx, x to the power of n, differentiation with respect to x. Denominator shows with respect to x is n into power into x to the power of n. In place of x, t is there, t cube. So 3 is in place of n, 3. T to the power of 3 minus 1, that is 2. 3 t square. But at 1 second we require. So V bar instant at t is equal to 1 second. Substitute here, that is in place of t 1. So 3 into 1 square. So 3. What are these 3 meters per second? 3 is the meter per second. Clear? 3 t square. In place of t, I have substituted 1. So 3 t square. Similarly, at t is equal to 2 seconds. So V instantaneous, after differentiation, we got how much? 3 t square. At t is equal to 2 seconds. Substitute in place of t 2 square. So 4 into 3, 12 meters per second. That means instantaneous velocity at t is equal to 1 second, 3 meters per second. And at t is equal to, time is equal to 2 seconds, 12 meters per second. Is it clear? Right. Let us solve another question. Displacement and time are related as s is equal to t square. Find average velocity in between t is equal to 1 second and t is equal to 3 seconds. This is the question. Observe carefully. Displacement time relation is provided. S is equal to t square. Clear? He requires average velocity. His interest is average velocity in between t is equal to 1 second, t is equal to 3 seconds. Particularly in between those 2 points required. Let us solve this question. Observe. Let us say this is the journey, long path of journey. And this is the origin from where journey starts. As the journey is proceeded, okay, time passing is t is equal to 1 second. Again, as the journey proceeds, time is equal to t is equal to 3 seconds. During the journey starts from origin. I am assuming journey starts from origin. And as time passes up to 1 second, there is a journey goes on. And again, up to the time 3 second journey goes on. Clear? Now I am giving some names to these points. Let us say this point is A, this point is B. Now, whenever average velocity is required, this is associated with the long path of journey. So E requires in between A and B, in between 1 second and 3 seconds. Here I clearly write average velocity is required in between t is equal to 1 second and t is equal to 3 seconds. That means in between A and B. In between A and B. In between. Now, what is the formula of average velocity? You know, V average is V bar vector quantity. Delta S by delta T. Change in displacement by change in time. Change in displacement by change in time. We can also write the total displacement in between A and B by the total time period in between A and B, because in between A and B is only required. Now observe. If I say that from the origin, beginning of the path up to the B point, displacement is S2. And from origin up to the A point, displacement is S1. In between A and B, what is the displacement? S2 minus S1. So change in displacement is S2 minus S1. Clear? Similarly, if I require the change in time in between A and B, if I say this as T2, 3 seconds as T2 at B, and this as T1 at A, what is the origin to up to B? Time taken is T2. Origin to up to A, time taken as T1. So in between A and B, because he is interested in between and T2 minus T. So this is divided by change in time in between A and B is T2 minus T. So ds by dt is change in displacement in between A and B, S2 minus S1, divided by change in time in between A and B, T2 minus T1. Clear? That is the formula. That means you require S2, S1, T2 already know, T1 already. Clear? Now, let us take up. What is the relation given? Relation given is displacement S is equal to T square. So we require S2. S2 is displacement at T is equal to 3 seconds. 3 seconds. So S is equal to T square. Substitute T square. T square is 3 square. So 9 meters. Similarly, S1. S1 is what? Displacement at T is equal to 1 second. So relation is given. So substitute T square, which is equal to 1 square. So displacement is 1 meter. So here I highlight S2 displacement at 3 seconds is 9 meters. And S1 displacement at 1 second, that is 1. Clear? Now I am directly substituting in the formula. That formula is V average, V bar average vector, delta S by delta T, change in displacement in between A and B by change in time in between A and B, T2 minus T1, which is, this S2 is 9 meters, S1 is 1 meter divided by T2 time 3 seconds, T1 time 1 second. So 8 by 9 minus 1, 8 by 2, which is equal to 4 meter per second. Average velocity is 4 meter per second in between A and B. Okay? Change in displacement in between A and B divided by change in time in between A and B. Okay. Now, let us solve another problem. That is third one. Yep. S is equal to T cube minus 6T square. Find velocity at T is equal to 1 second and at T is equal to 2 seconds. This is the formula. The relationship between displacement time is this, and he is asking velocity at S is equal to 1 second, S is equal to 2 seconds. Here, let us solve this one equation and be careful in the problem. At T is equal to 1 second, velocity is required. Means at a particular time, at a particular instant of time. That means instantaneous velocity is ds by dt. Similarly, at T is equal to 2 seconds. Again, at a particular instant of time, 2 seconds he requires. Again, ds by dt. Clear? So, first let us differentiate this equation. Let us differentiate this equation. That is V instantaneous, which is equal to, this is the solution I am providing. So, ds by dt, this is the formula. Instantaneous, at a particular time, So, differentiate this. So, 3t square minus 6 into 2t. 2t. So, this becomes 3t square minus 12. 12t is V instantaneous. V instantaneous. It is square after differentiation, ds by dt. Dt square minus 6 into t square differentiation is 2t. So, completely 3t square minus 12. Here, 3t square minus 12. So, here, V instantaneous is 3t square minus 12. Now, at what time he requires? At t is equal to 1 second. Substitute here in this 1 second. So V bar is equal to 3 into 1 square minus 12 into 1 becomes 3 minus 12. So which becomes minus 9 meter per second. Minus 9 meter per second. Minus indicates because velocity is a vector quantity in the reverse direction. Clear? And similarly, at t is equal to 2 seconds. T is equal to 2 seconds. So V is instantaneous. So here V bar instantaneous Substitute 2 seconds here. So 3 into 2 square minus 12 into in place of t 2. So 12 minus 24 becomes minus 12 meter per second. Again, it is vector quantity. Negative sign indicates reverse direction. And 12 indicates magnitude. Negative sign indicates reverse direction. Is it clear? Those are the instantaneous velocity at a particular time. T is equal to 1 second and T is equal to 2 seconds. Okay. Clear? Now, let us take up another problem. Clear? If the relation between displacement and time is s is equal to t cube minus yeah, s is equal to t cube minus 6t square. Find the time when the body is at rest. When the body is at rest. Observe carefully. Relationship between displacement time is provided. This is the relationship. And it requires the time. He is asking no time. He is interested in time. When the body is at rest. What is the meaning of body at rest? Body at rest means velocity is 0. When there is no velocity, body is at rest. So that is the meaning of that. Body is at rest means velocity is 0. Velocity is 0. Clear? Now observe. What is the relation given? S is equal to t cube minus 6t square. This is the relation provided to us. Okay. What is velocity? Velocity is simply defined as v bar ds by dt, which is equal, differentiate it. So 3t square minus 6 into 2t. So it becomes 3t square minus 12. This is the velocity. So observe, velocity v bar is 3t square minus 12. At rest means v bar is 0. Substitute this is equal to 0. So 3t square minus 12t is equal to 0. So observe, 3t square, 12t is equal to 0. So 3t is common. T minus 4 is equal to 0. So 3 cannot be equal to 0. Number cannot be equal to 0. That means there is only possibility that either t is equal to 0 or t minus 4 is equal to 0. That means finally t is equal to 0 or t is equal to 4 seconds. The body becomes at rest. At t is equal to 0, the body is at rest. Time is equal to 0, the body is at rest. Or at t is equal to 4 seconds, the body is at rest. Clear? So these are some of the problems that are associated with the velocity, instantaneous velocity and the average velocity. Take into account. So practice well. These are very simple problems. Initially, we are going with the simple problems. Later, we go for the advanced level of problems. Like the video, please share it and subscribe. Thank you very much.